Hey you! Yeah, you. Do you know why that happened? No? Well, looks like someone forgot everything about their basic middle school science class. But that's alright. With this video, you can remember everything you forgot from these days. But first, let's roll out introductions first.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape of an L.
My name is Saitaullah Falk, and today we're going to be teaching you about Newton's 3 laws of motion. These 3 laws are important to us as they tie into almost everything we see in life, such as how things move or why things stay still.
Newton's first law is called the law of inertia. This is when an object at rest tends to remain at rest, and when an object in motion tends to remain in motion at a constant speed, along a straight line path, unless acted upon by an outside force. Imagine a book on a table at rest. This book will stay at rest forever because it is at equilibrium, unless an external force acts on it, causing it to move. Similarly, imagine a car going at a constant speed and taking your foot off the gas pedal. In theory, the car should stay in motion at that constant speed. However, it slows down because of friction, an outside force, acting on it. See how this book is at rest? It will stay at rest forever because it's at equilibrium. However, when I exert a force on it, I cause it to move because it's an external force acting on it, which changes its motion. Okay, good.
Newton is called the law of acceleration. Is when a net force acts on an object. The object will accelerate. The acceleration is directly proportional to the net force and inversely proportional to the mass. For example, consider 2 seats, one with a person sitting in it and one that is empty. If you were to push the 2 desks with the same force, you will find that you push the empty desk with more acceleration than the one with the person in it. That means more force is needed to push the desk with the person in it.
It is to push this chair with no one inside of it. It's much harder to push someone with the same exact force as before. Action-reaction. Whenever one object exerts a force of a second object, the second object exerts an equal and opposite force on the first object. That you punch a wall with your fist. Your force with your fist and an equal and opposite force applied by the wall on your fist are present. Hence, the harder you hit the wall, the more force is exerted on your fist by the wall. As you can see, the harder you hit the wall, the more force is exerted on your fist by the wall. Thank you, Towel.
Newton's 3 laws are both simple, yet are significant in our everyday life. The law of inertia, acceleration, and action-reaction forces are key laws to remember as they dictate a numerous amount of how things move and work. Hopefully you benefited from watching this video.
It's pretty easy pushing this chair. Pushing this chair. When I push with some what I say? See, it's much harder to push someone with the exact same force.
You didn't say my name.
Oh yeah, I need to say your name. I'm sorry.
Upper. Okay. 2 hands can't be in. You hella did. He moved his head. Punch a wall with your fist. Force with your fist and an equal and opposite rate force applies. What? Where is it?
What are you doing in my swamp?